RASC Toronto Centre. I would like to start by acknowledging that the Royal Astronomical Society of Canada Toronto Centre meets on the traditional territories of many Indigenous nations, including the Haudenosaunee Confederacy, the Huron-Wendat, the Mississaugas of the Credit First Nation, and other Anishinaabe peoples. These lands are part of the Dish with One Spoon Treaty and are now home to many diverse First Nations, Inuit, Métis, and Indigenous peoples from across Turtle Island. As we engage in astronomy here, together we respect, learn from, and honor the deep relationship between Indigenous peoples, the sky, and Earth. Tonight, we are going to the moon, virtually anyway, in celebration of the Artemis Mission, which is launching soon. I will be joined by Dr. Bhairavi Shankar, a planetary scientist, Chris Vaughan, our astronomy outreach expert, and three observers, Ian Wheelband, Dennis Gray, and Francois Van Heerden, who are going to show us what you can find on the moon with a little optical help. Now, whenever you're dealing with space, you're going to hear lots of initials. Maybe some of you are familiar with them, but I'm going to run over a few for you to listen up for tonight. First, RASC stands for Royal Astronomical Society of Canada. We are from the RASC Toronto Centre, and there are 29 other RASC centres, which are like local clubs that work together to promote astronomy and space sciences in Canada. You can find out more about us at rascto.ca, and if you're tuning in from elsewhere, find your own centre at rasc.ca. We'd love to welcome you to our club. CSA stands for Canadian Space Agency. This is an agency of the federal government, and it's famous mostly for hiring astronauts like Roberta Bondar, Chris Hadfield, and David Saint-Jacques. But it is also a vital hub for the very active Canadian aerospace industry. You probably know that Canada was a very early nation in space, the third in fact. Had a satellite in orbit when Alouette 1 was launched in 1962 as a communications vehicle. And Canada remains one of the world's leading players in aerospace. NASA is, of course, the National Aeronautics and Space Administration. You've probably heard of them. They look after the United States space endeavors. ESA is the European Space Agency, and JAXA, the Japan Aerospace Exploration Agency. All of these agencies and some companies, including Canada's own MDA, are collaborating on the Artemis mission. Now, Artemis isn't initials. She is the ancient Greek goddess of the moon and the hunt, and the sister to Apollo. That's a fitting name for a project that will take humans, including a woman and a person of color, back to the moon for the first time since 1972. Artemis is ambitious and includes building a space station in lunar orbit, that's known as the Lunar Gateway, and also laying the foundation for a long-term presence on the moon, a moon base, and also the foundation for missions farther out to Mars. As the torchbringer, Artemis will light the way for human exploration of the red planet. But enough of me and enough of these initials. You're here for the interesting people. We're starting tonight with Dr. Bhairavi Shankar. Bhairavi is a planetary scientist, an educator, and founder of IndusSpace, which is a social enterprise that provides programs and products about space exploration to students from kindergarten through grade 12. Bhairavi, we're hoping you can tell us a little more about this exciting Artemis mission.
Thank you for that introduction, Kirsten. I'm excited to share with everyone the various aspects to the Artemis missions, and in particular, Canada's role in lunar exploration. As mentioned, the Artemis mission will be NASA's first crewed mission to the moon since Apollo 17 in 1972. The goal of Artemis is to establish the first long-term human presence on the moon. What the global community learns on and around the moon through these missions will help determine how to take the next giant leap. That is in sending astronauts to Mars. Artemis aims to land 2 astronauts, including the first woman and first person of color, near the lunar South Pole over the next 5 years, and to establish a sustainable human presence on and around the moon by the end of the decade. Kirsten already mentioned that Artemis is the mythological Greek goddess of the moon and twin sister to Apollo. The mission is set out in 3 stages. First is Artemis I. This mission will be an uncrewed journey around the moon that should launch in late May or early June this year. The purpose of Artemis I is to test the inaugural flight of NASA's Space Launch System, or SLS, a rocket that is taller and more powerful than the Apollo Saturn V rockets. The Orion spacecraft is a multi-purpose crew vehicle that will ride on top of the SLS. We're actually days away from the first dress rehearsal of Artemis I, scheduled for April 11th. This is an opportunity to test this SLS system, Orion spacecraft, and the exploration ground systems at the historic Launch Pad 39B at NASA's Kennedy Space Center in Florida. NASA will review data from this dress rehearsal before setting a specific target launch date for the Artemis I launch. This animation shows what is planned for Artemis I. After launching from the Kennedy Space Center, spend time in lunar orbit and return back to Earth with a splashdown in the Pacific Ocean. I'll let this play. And I'll encourage everyone to go over to the Canadian Space Agency's website to see this in full length. It's very exciting to see what's planned. So that tells you what's planned in Artemis I. Approximately 2 years after Artemis I comes Artemis II. During this mission, the SLS will carry astronauts on board the Orion spacecraft to an outpost called Gateway. The focus of Artemis II will be to study how deep space radiation, partial gravity, and distance from Earth will affect astronauts' health and performance. This mission should last about 10 days. Eventually, in the long term, Gateway will house astronauts on Artemis missions in lunar orbit and also allow crews to make trips to and from the moon's surface, with a human landing system in the works. You can think of Gateway as ISS 2.0. This outpost would be 1,000 times farther from the Earth than the ISS is. The Gateway will provide a living space for astronauts, research lab, and act as a mission control for any human exploration that happens on the moon's surface or beyond. The living quarters will be able to host crews of 4 astronauts. But unlike the ISS, there will not be continuous humans living on site. So astronauts will be able to live and work on the Gateway for up to 3 months at a time, and then travel to the lunar surface to conduct any science or test new technologies. As this picture indicates, it's a truly international initiative. And Canada plays a huge role. Canada will contribute the Canadarm3, a smart robotic system that includes a robotic arm and specialized tools that will be autonomous. Canadarm3 will use artificial intelligence to maintain operations in space when humans are not present. The role of the Canadarm will be to maintain, repair, and inspect the Gateway, to capture any visiting vehicles, to relocate any of the Gateway modules, to help astronauts during spacewalks, and to also enable any science that might happen in lunar orbit or on the lunar surface. With this huge contribution on Artemis II and to the mission, we've reached an exciting time, because with Artemis II, Canada will send our first astronaut on the mission. And so it will be one of our current crew members. And so we're all excited to see who that may be. And finally, Artemis III will be the first crewed landing mission to happen on the moon's surface. And there would be a Starship HLS lander. Artemis III is planned to be the second crewed mission after Artemis II, but also the first crewed lunar landing since Apollo 17. In this artist impression, you can see how the Artemis crew of 4 people would be in space for about a month, and they will alternatively spend time between the gateway and the lunar surface. And particularly, they plan to land at the lunar South Pole. This will allow to explore the potential of water ice that is known to be trapped in the region, and it will help astronauts plan for future permanent presence on the moon. Over the next 5 years, Canada has set distinct goals in placing a lunar rover. The CSA has awarded, hoping the video will play. The CSA has awarded 2 Canadian companies to design a lunar rover mission. Apologies. I will mute the audio. 2 companies to design a lunar rover mission to the moon that would explore the South Pole. This opportunity has opened doors to further collaborations among several small, medium, and large companies and universities across Canada to collaborate towards this national vision. The rover mission will ultimately demonstrate key technologies and accomplish meaningful science. The rover will carry at least 2 science instruments, and the mission will aim to gather images, measurements, and data on the lunar South Pole, and also test how a rover might survive a lunar night, which can get pretty cold. This is truly exciting times. And with that, I will pass it back to Kirsten and encourage everyone to follow and cheer on our Canadian space community as we embark in this journey exploring the moon and beyond. Thank you.
Thanks, Bhairavi. It's fascinating to see all the moving parts. Now, I was 1 when the last Apollo mission landed on the moon, but those missions definitely shaped my interest in space, and I'm sure many of the others here on this broadcast tonight are the same. Many of my fellow members of the RASC are likely the same too. We were kind of wondering what the next generation thinks, so I asked my resident teenage daughter what she thinks about the moon and about the Artemis mission. So we're going to hear a little pre-recorded Q&A with Julia.
When I first looked through a telescope at the moon, it didn't really click in my brain that these were like huge craters that can be kilometers deep. So seeing it in a telescope was pretty mind-changing for me. I hadn't really heard of the Artemis mission before coming on here to do this. Normally my class would talk about things, like my teachers would talk about things like this, but they actually didn't this time, so I've never heard about this mission. It's been brought to my attention that they're going to be making a moon base and a space station, so that's pretty awesome. Establishing a base on the moon is pretty important, in my opinion, because you need a home base to be able to set up scientific research and everything. You need a place where you get all the information, collect it, and then do that actual research. I also think it's pretty important that actual humans are doing the research, because if robots do it, they won't have stories to tell. People who do TV and everything, they interview astronauts, and if they interviewed a robot, it would be so boring and horrible for people to watch. Would I be interested in going to the moon? Honestly, not now, because I know technology is so advanced, but I just don't trust it enough to feel comfortable, so I'd probably go later in time. Do I think I'll have an opportunity to go to the moon? It depends how life plays itself out, but I suspect yes. What made me interested in space? Honestly, it was the endless possibilities. I could just zone out and think about everything. There's so many things that could be in space, example, aliens. Is there an end? What could be happening right now? What happened in the past? What will happen? It's just so interesting to me.
So I think we may have a little bit of work to do to get people more aware of the Artemis mission. So it's not quite gotten into everybody's consciousness yet, but that's part of the reason why we're here tonight. But you know, you don't actually have to go to the moon to explore it. It is one of the most accessible celestial objects in the night sky. Our resident night sky explorer, Chris Vaughan, is here now to tell us how you can explore the moon from your window, your balcony, or your backyard using only your eyes or a pair of binoculars. Chris is a regular contributor to Sky News Magazine and to Space.com, and is the senior astronomer and earth scientist at astrogeo.ca, which delivers virtual presentations and portable planetarium visits for schools and private groups. So, over to you, Chris.
Thanks, Kirsten. So I'm actually gonna simulate the appearance of the night sky using a program called Starry Night. And what I'm doing right now is I'm showing you a virtual sort of simulation of what the sky looks like, what the moon looks like in the sky this evening, a little bit before 8 p.m. local time, or just around the time the sun is setting. Now, when can you see the moon? We can see the moon almost every day of the month. The only time we miss it is when it's passing the sun at new moon, when we lose sight of it for a couple of days. But for the rest of that period, it spends about half of the remaining time in the evening sky when we can see it after dusk. And then the other half of that time in the midnight to dawn sky where we can see it before dawn. So, you know, you may think the moon is missing, but it just means you're not getting up at the right time of day or staying up late enough to see it. Now, the moon phases are dictated by the angle that the moon makes with the sun in the sky, because the sun is the illuminator of the moon. And tonight on April 9th, we're just around the first quarter phase of the moon. So it's around a 90-degree angle between the setting sun here and the moon I've got in the sky. But of course, the moon's phases vary night by night as the angle of the moon with the sun varies, because the moon is circling the Earth. The moon orbits the Earth once every 27.3 days, but the phases only repeat on a different time scale. They repeat every 29.5 days. And that's because the Earth at the same time is moving around the sun. And so the geometry extends that period between repeated moon cycles. So here we've got the moon in the sky this evening. And of course, as everybody knows, if you wait, you know, look at the moon at the same time tomorrow night, it'll wax in phase a little bit. It'll rise a little bit later, and so linger longer in the evening sky. I'll just bring this up a little bit higher. And as it's doing this, it's increasing its angle away from the sun by about 12 degrees worth of sky every night. By the time we get to the next week, we're going to get the full moon in the sky. And what's a fun exercise to do is to, even though when the moon looks huge when it's rising in the eastern sky at sunset, hold up your pinky finger, hold it out at arm's length and close one eye, and you can always cover the moon with your pinky finger. And what's neat about this little trick is that it even works for young kids. And that's because their fingers are smaller, but their arms are shorter. And so it works for our humans of any size. Now, the moon itself is about smaller than you probably think it is in reality. It's about 3,475 kilometers in diameter, or about 27% of the Earth's diameter. And so you could actually tuck the moon between Vancouver and Kingston, Ontario. So it's, you know, not even as wide as Canada is. Now it's about 400,000 kilometers distant, so but it varies. It has an elliptical orbit, and that makes it come nearer and farther from the Earth. And I'm just going to bring up a little diagram here that shows some of this and set this to running. And the elliptical orbit brings the moon within about 360,000 kilometers, and then at times it'll reach to about 405,000 times. And if you could get in a car and find a highway to the moon and never have to stop for gas or food, it would take you about 6 months to drive there. That's how far away it is. And just FYI, forget traveling to Mars. It's 200 years at least to get to Mars in the car. Now, the moon, as I said, because it varies its distance from the Earth, it actually looms a little bit larger and a little bit smaller at times. And when the cycles between the phases and the orbits line up so that it's a full moon when it's closest, we get a so-called supermoon. And the next supermoon that's going to happen for us, I think it's on June 14th. So the June 14th full moon will be considered a supermoon. Now, astronomers don't really worry too much about the term supermoon, but if it gets people to read about it in the news and head outside to look up, we're happy about that. Now, when you look at the moon, let me just bring up a moon here. Hold it steady so we can get a look. When you're looking at the moon in the sky, just with your unaided eyes, you're seeing patches of dark and patches of light. And the lightest areas of the moon are the most ancient parts of its crust. So they were when the moon first coalesced, the sort of light crystalline and orthosite rocks floated to the top, made a skin or a crust around the sphere of the moon. And those have been around so long that they've been battered by impactors, and that's why they're so heavily cratered. The dark areas on the moon, though, those are actually impact basins. So some of the most enormous objects that slammed into the moon carved out or excavated bowl-shaped, basins in parts of the moon. And later on, they were actually flooded with dark colored lava, sort of iron-rich heavy lavas that upwelled from the interior of the moon and flooded them. And they're actually, they're still quite old surfaces, but they're much younger than the highland areas. And so when you look at the moon on a night sky, you can see these sort of, it's not necessarily round, but sort of roundish shaped dark patches, and those are these basins that have been later flooded. And of course, the basins that were created after the earlier ones have come in and kind of overlain or overwritten its neighbors, and so you get a little bit of distorted shape. So they're not a lot of clearly round patches you can see in the sky. One of our telescope operators is actually going to zoom in on Mare Crisium here in a little bit, and that's one of the most distinctive lunar basins. Now the craters that you see on the moon are named, and they're actually a lot of the nomenclature and the names that you see here, these funny Latin names that I've got here on the lunar basins. Those are Latin expressions, and they were actually coined by a Jesuit priest named Giovanni Battista Riccioli in a map he made back in 1651. And we've just taken those names and added to them as we've sort of zoomed in on the moon and found more and more craters. And he did some interesting things. So he put he named the craters after scientists and their proteges. He tended to put the more ancient scientists in the northern part of the moon, so it's sort of the Greek scholars and things like that. And then his more modern sort of contemporaries towards the southern parts of the moon. Now, people like Copernicus and Kepler, who were promoting the heliocentric model of the universe, which was, against the teachings of the church at the time, he decided he couldn't skip them because they were so famous as scientists. But what he did to accommodate that is he put them in the Sea of Storms. So the large dark patch on the right, sort of the western half of the moon, the left-hand side here is the Sea of Storms, Oceanus Procellarum. The other Mare, he actually named after weather and human opinion, human attitudes or feelings. So you've got the Sea of Cold at the top. You've got the Sea of Serenity, Mare Serenitatis, and tranquility and fertility, and so on. So those are the light areas and the dark areas that you can just see just by looking up on a usual night. By the way, the next lunar eclipse is going to happen on May 15th. So mark your calendars for the evening of May 15th, when the moon will dip into this dark patch in the sky. This is the shadow cast by the Earth against the stars beyond it, and the moon is going to run through the shadow. It'll dip into the shadow in late evening around just before 10 p.m. and then pass through the shadow through much of the middle of the night. So mark your calendars for that. Now, what if you get binoculars and take a look? So let's go back to my view of the moon in binoculars. And I've got another one that's labeled up here. Let's see. Yeah, there we go. So when you look at the moon in binoculars, you'll notice that the Mare regions are, as I said, fresher, less cratered, less scarred than the lunar highlands are. You want to pay attention to the fact that not all the Mare are the same. So some are lighter, some are darker, and some even have darker rims around the edges. And those are due to the chemistry of the basalt varying over time. So you would have an initial flood that fills the basin, and then you might have some subsequent lava coming in at different times that have a different color or different chemistry to them. You'll notice that some of the more prominent craters are the brighter ones, and those are the fresher ones, the freshest ones on the moon, the more recent ones. And when you're looking at those, you'll notice that a lot of them have streaks or rays emanating away from them radially. And one of the most famous is this crater Tycho near the bottom center part of the moon. And the rays are these streaks that you can see extending radially away from the crater. And you'll notice that if you look around, that lots of the craters have these streaks and these little sort of white marks that stretch across some of the mare. And whereas Tychos tend to be very straight and linear, the ones around Copernicus, which is this crater over here in Oceanus Procellarum, tend to be a little more raggedy, a little less linear than the ones around Tycho. In a telescope, some of them are revealed to be little pits of secondary impact craters and things like that. And I think Dennis is going to show us some impact rays, some really interesting ray systems a little bit later. Last up, you want to look for things like the edge of this big Imbrium basin. This is actually what we now call mountain ranges. So even though they're actually basically a crater rim, we consider the mountains, and we actually named the mountains on the moon after terrestrial mountains. So we have the Alps here, we have the Apennines, we have the Caucasus Mountains. And again, if you're looking at binoculars, see if you can spot this scar that cuts through the Apennine, the Alps mountains here. That's a fault where two cracks in the moon's crust were parallel and the crust in between them dropped around below. Just a couple final thoughts, in terms of scale, when you're looking at the moon and you want to sort of think about how big it is. Most of the craters, the noticeable craters that you see on the moon, they're about 100 kilometers in diameter. So just to give you a sense of the size of things. The big Imbrium basin, it's over 1,000 kilometers in diameter, and Mare Serenitatis here, it's about 675. So we'll switch over to some of our telescope operators for some really close-up views, but those are some of the things that you can take a look at for yourselves without any special equipment. So I'll send it back to you, Kirsten.
Great, thanks, Chris. Chris, we had a couple of questions come in while you were showing us the moon there. One of them is something that Eric asks, and something that you may have noticed is that in the wintertime, we really notice the effects of the full moon because it's so high up in the sky, and yet in the summer, the full moon seems to sort of float low in the sky. Do you want to explain why that happens?
Sure, yeah. So if you look at this diagram I've got here right now, the green arc across the sky, that's the ecliptic. So that's the track that the sun takes in the sky. And you can see that the moon, it's within about 5 degrees of the ecliptic. When it's right on the ecliptic, that's when we get eclipses, but it wanders along a path parallel to the ecliptic within a few degrees of it on either side. Now, in the summertime, the sun is up in the daytime, the moon is up at the nighttime. The sun is very high in the sky. And conversely, the ecliptic in the nighttime sky is low. And so the moons tend to be low. The full moons opposite the sun tend to be low in the summer months. Whereas in the winter, it reverses. So the sun is low in the sky in December, but the full moons in December, January, February are extra high in the sky. And actually, if you look at the shadows cast by the full moon in winter, it's the same shadows you'll get from the trees in your yard and maybe the tree house or the play set, climbing set you have in your backyard by the noonday sun in the summertime. So yeah.
Cool. We actually had another question from Zapfan, who's joining us from Sweden. Hello. He wonders what you think of Andy Weir's book, Artemis, or if you've read it. Now, he didn't ask me. I read it, and I really enjoyed it, but he wondered what you think of it.
Yeah, I really enjoyed it too. I love the in situ resource utilization, where they were using, the humans that settled the moon are using the material of the moon, of the lunar crust. The anorthosite crust are aluminum silicate rocks, and that means that there's oxygen molecules mixed into the structures of those crystals. So Andy talks about extracting out the aluminum for building structures, and taking the oxygen out and using it for fuel and breathing and things like that. So he's great. This is the real science he puts in is great.
Definitely. Actually, Julia, that teenager, is reading Project Hail Mary right now and really enjoying it, which is Andy Weir's new book. Definitely a good book. Okay, Chris, I think we're going to go and try and get some live views now.
Yeah.
So we have 3 observers who have telescopes, and just to try and catch some clear sky, we have one located near Toronto, one of them out in Trenton, and one in Nova Scotia. But I think it's possible we've struck out in all 3 locations. However, that's okay, because if we are not able to get a live view, we've got some great live video views. So first off, we're going to go to Trenton, Ontario, and visit with Francois Van Heerden. He's a seasoned observer and member of the Toronto Centre. And I hear, Francois, that you've got some Apollo landing site locations that you wanted to try to show us. What can you actually see there?
You don't actually get to see the landers, unfortunately. They are far too small. It's like trying to see a dime with your unaided eye at 300 kilometers sort of thing. But we know the general areas, and we do have a number of satellites circling the moon that actually have photographed the locations, and we can actually see where the footsteps and the driving trails were. So in the Sea of Serenity, or Mare Serenitatis, we have one up here, and that is one of the landers that we had, and that one was right up here. It's Apollo 17, which landed at the Taurus Littrow Valley, so right approximately where the hand cursor is here. If we go over here, still in the mountain ranges here, we have Apollo 15, and it basically landed in this general vicinity here. However, the Sea of Tranquility, where Apollo 11 landed, is just above that little crater that the index finger of the cursor hand is pointing at, so just slightly above that. And then if we go just a bit further down, we get the Descartes Highlands, which is over here, and that is where Apollo 16 landed. Now, this image was actually taken last night by me and then processed. The film was actually processed so that I could bring out the details and some of the colors of the surface of the moon. So those are the locations, and the reason why we went to each of these different locations when we sent the Apollo missions is because the geology and the very terrain is different, and we wanted to know what was going on. We were able to do that, and we got some great science. They just opened fairly recently the last of the repositories of lunar material and are now analyzing it. So it's going to be interesting to see what else we get coming out of that. But overall, you cannot see the actual individual landers, but you can find actual footage of what they did discover there. Back to you, Kirsten.
Thank you, Francoise. Just curious, that image you were showing was one that you actually took yourself?
Yes, I took it last night as a video and processed it overnight and this morning.
And I'm assuming you're clouded out tonight.
I am completely clouded out. In fact, it's raining here now.
Oh dear. Well, welcome to the hobby, right?
Exactly.
Yeah. It's one thing they don't have to worry about on the moon, at least. It's a good place for a telescope. I think Arthur C. Clarke had a story about a telescope on the moon.
He did.
Maybe we should think about doing that as well. Okay. Well, thank you, Francois. Now we're going to come back to the Toronto area, and Dennis Gray, who has a telescope set up where I think he too is clouded out. However, we always live in hope. Dennis, you are going to show us some other features on the moon. What have you got for us?
Well, I've got some stuff I'll show in a moment, but I'm just going to give our viewers a chance to sort of see what I was working with here. So this is the scope gear that I was using last night when I took some contingency video here. So I think you can just see my gear out there. I'll just wander over here, and you can see this is the telescope part here. Is this stubby tube that goes from here to here, and this is the CCD camera that goes in there. So that's pretty well much like your cell phone camera or DSLR camera, but it's been designed with a cooling system, and it can take really rapid shot. So this camera can do an exposure as short as like 1/8,000th of a second, which is really helpful for a really bright thing like the moon, because it allows me to reduce the light down to the point where I can actually see what I'm looking at. Otherwise, it would all be blown out and overexposed. So unfortunately, it was all ready to go, but it is, as you say, it's pretty well socked in here. But at least it's not raining like it is in Trenton.
Yeah. And you're in downtown Toronto, right, Dennis?
Yeah, I'm in downtown Toronto. The moon's one of my favorite things to see because it's one of the few things I can see.
Yeah.
Anyway, let's take a little look at the edge of the moon here, and one of the things I just wanted to sort of highlight a couple of things on the eastern edge of the moon. So this is video I took last night, and this is a wide angle view of the moon, and it's kind of close to what you might see if you look at the moon without your with binoculars, or even without anything at all. Just look at it. You can see the Mare that Chris was talking about, the bright and so forth. And there's one Mare that is kind of special. And this is Mare Crucium, the Sea of Crises, it's known. And it's the only Mare that we can see on this side of the moon that's all by itself. So it's actually a distinct spot. All the other Mares are connected from one Mare to another. And like most of the Mares that we can see on the moon, it's actually a gigantic crater. And when they're this big, they stop calling them craters and they start calling them impact basins. So here's another one down here. That's another impact basin. And you can see, like, they just get to the point where they're so large that they kind of crack the crust. And what's happened is that lava has welled up from inside the moon. This happened billions of years ago. They dug out a huge hole, and lava filled the hole up, which gives us this distinctive colored, darker color sea on the edge of the moon. Now, Crisium itself is about 570 kilometers wide, so that's roughly the distance from Toronto to Montreal. So that's where I'm showing my cursor there. That if you were able to drive that, that's your drive to Toronto to Montreal. Stop here in Kingston for some Tim Hortons, and carry on. And you would be essentially working out there. And if you just see this little peninsula sort of sticking out there, that's Toronto. Roughly, that's about the size of Toronto right there, kind of thing. The thing that's kind of cool about this particular Mare, which I like to point out to people, is that this one is the one where you can actually see a really cool thing called libration. As Chris was mentioning, the moon's orbit is elliptical. Sometimes it's closer to us and sometimes it's further away. And when it's closer to us, it goes a little faster, but it's always rotating at the same pace. It rotates once every month, or every month. That's the word month came from, in fact. And so what happens sometimes is you can see that the moon's rotation kind of gets a little bit ahead of itself, and then it goes, oh yeah, I'm slowing down now, I'm going on the other part of my orbit, and then the rotation seems to come back. And what you'll see is this edge of the moon will get a little bigger, a little smaller, a little bigger, a little smaller. And if you're looking at it with binoculars, you'll see things on the edge of the moon, like this little Palus Somni. It's a marshy, it's considered to be a marsh, but you would see that this is a little further, the edge, and then when it's in its most maximum libration, you can actually see that this crater, or this basin, isn't round. It's actually a little oval, and you can see that when it's facing us a little bit more. So it makes it for a really cool measuring stick, if you will, about where the moon is in its orbit. I'm just going to switch things up here and show my other video, because I did do more than one last night. And what I did was I switched my camera up, and when I switched my camera up, I was able to go to a higher magnification. So that's my wide view, and then this is my sort of up close and personal view here, which gives us a little bit better view of everything. Now, one of the things you'll notice is that the brightness on this video is going up and down, because I was fighting clouds big time last night. They were coming and going and coming and going. You can actually see that little haze sort of moving up and down. That's not on the moon, that's between me and the moon there. And what's happening is I'm having to on the fly adjust my exposure, because when the moon comes out from behind the clouds, it starts to brighten up a little bit too much. And then I reduce the exposure a little bit so that we still get a good view of it. But one of the things I wanted to show you is this really cool crater here called Proclus. Proclus is an interesting ray crater. It's about 28 kilometers wide, and it's just on the edge of Crisium. And so you could drop London, Ontario in there, and it would rattle around nicely. And that kind of gives you an idea of the size. But what's interesting about Proclus is that it's got this ray system. It's 220 degrees wide, so it's kind of like that clock face, and it's kind of like showing 7 o'clock there. If this was 12 o'clock, it would be showing about 7 o'clock. And there's this evidence here that this is what's actually an oblique impact. And one of the things that we found about the moon was there was this huge controversy about a little bit less than 100 years ago, because when everyone looked at the moon, they looked and they saw these craters, and they say, well, okay, well, they're craters, obviously. What kind of craters are they? And the only analog we had on Earth was craters volcanic. So there was a lot of people, chatty British eccentrics, a lot of them, arguing that these all were volcanic craters. They weren't anything else. And when they said, well, of course they're volcanic. Look, they're all round. And their argument was, well, they're all round because they're all volcanoes. And if they were impact craters, well, surely they would be coming in from all these different angles, and they would have all kinds of different shapes. And it wasn't until the 1960s when a fellow named Gene Shoemaker and some of his colleagues started to do some experiments with what they called hypervelocity impacts, where they started to shoot things really, really fast at the ground, that they realized that only if the impact angle is really, really sharp, really, really subtle, will you actually see anything other than a round crater. The explosive force of things blowing up when they hit the ground is so huge that it really doesn't matter if it's coming in at 40 degrees or 50 degrees or straight down, you still get a round crater almost all the time, unless it's something like Proclus here, where it came in at a very tough angle, and this is about 15 degrees. It came in really, really shallow, hit that, still made a round crater, but it created this zone of exclusion, which we see as this interesting 7 o'clock shape here, right on the edge of Crisium. So anyway, I think there's some more cool stuff to be found. There's all kinds of stories to be found on the moon, but that's one of my favorites, is just exploring that and keeping an eye on Crisium. Every night when I look at the moon, I look at it and see how is the moon doing tonight? Is it ahead of itself or a little bit behind?
Excellent. Thank you very much, Dennis. I had not heard about the eccentric English moon theorists who thought they were all volcanic. That's quite interesting.
Oh, you've heard of Patrick Moore, of course.
Oh, I've heard of Patrick Moore, yes.
He wrote entire books about his theories.
Yeah. Well, the science of astronomy is littered with eccentrics writing books, I think.
Exactly.
But, and here some of them are in the room tonight. There you go. Thanks so much, Dennis. We actually got a question, I think, from Francois's talk there. But in fact, before we go, Dennis, are you still with us there?
Yes, I'm still with you.
Do you know if there's a crater named after Gene Shoemaker?
Well, there's more than one comet named after him. I wouldn't be surprised if there isn't something there, but it would probably be very small. And if there was one, it would be very small. It would probably be on the far side.
Right.
But yeah, that's a good question for somebody to quickly Google up the answer.
Yeah, I was thinking that.
I can show it. Switch to me, I got it.
Show it. Perfect. Chris Vaughan's got Shoemaker crater. There you are.
There's Shoemaker down here.
Well, we move over to Chris. Just so you know, Chris is using a neat piece of software called Starry Night, which is very powerful and very cool. So it's something that you can purchase. There are other options as well. Well, we get that. We also had a question from, where have we got? Shoemaker. We got that? Yeah, excellent. There it is. Oh, right on the. So it's on the near far side, eh, Chris?
No, it's near the pole. I'll mark it again. I'll
Okay.
mark it
Yeah.
again.
Yep. No, I saw you. I saw it there. Just a little delayed. We had another question that Bhairavi might be able to answer since she's a planetary scientist and good with the surface of the moon. Somebody asked about the orange soil and what that might be. Do you have an answer for us, Bhairavi?
Yeah, so for anyone who was curious about what is the orange soil, this was observed by the lone geologist on the Apollo missions, Harrison Smith, who observed an orangey patch during the Apollo 17 missions over by Taurus Littrow. And so what are these orange soils? And so they believe that these orange soils are really glassy beads that came from a volcanic eruption that happened, rather quickly, but also cooled really quickly. So there wasn't any chance for any crystals to form. Rather, it was just glassy beads. And so this was likely created about 3 billion years ago, and that's what remained on the surface. They don't quite have specific idea on the exact composition, except to know that it might be volcanic in origin. And with soil, it's really hard on the moon to figure out the exact source of it. It could be crust, it could be just powdered crust that has happened because of cratering, or just a lot of gardening, so movement of the soil through all these sort of impact events. And so what we know is that these orange soils have a volcanic origin in nature.
That's perfect, because we had another question. Is there volcanic activity on the moon?
Not currently. This is again back in the early days of the moon. But they were large and extensive to the point that they could fill these impact basins. So everything that you see that have the darker tinge on the near side are all volcanic flows that have filled into impact basins. But really, they don't believe that there has been any current volcanic activity. It's really billions of years ago in the early days.
Okay. I'd just like to point out that term gardening. I love it. Gardening on the moon.
Lunar gardening.
Lunar gardening means when new impacts come down and cover up things and move things around. I think that's fantastic. Very evocative. All right. Thank you very much, Bhairavi. We are going to now take a trip out to Nova Scotia and visit with Ian Wheelband, who's another member of the Toronto Centre who spends some of his time down east. And Ian, how are your skies tonight? Have you got anything for us to see? Okay. Unfortunately, Ian's audio isn't coming through all that way. I guess the electrons got tired coming from Nova Scotia. So I believe what we're seeing here is a video that Ian took, and what it is showing us is the south pole of the moon. I don't know that we have that showing right now, but what we are hoping to get, Ian took a video of the area where they are hoping to establish a presence, hoping to land the Artemis mission and establish a presence there. So this is the south pole of the moon. And if I am reading Ian's notes correctly, why they would like to go down to that area is, as we were talking about the book Artemis, by Andy Weir, he talked about using resources from the moon, and this part of the moon has, in fact, got some water ice lurking at the bottom of the deep craters that don't get any sunlight. So any water ice that is impacted on that part of the moon can exist in those craters sheltered from the sunlight. And Ian has helpfully put his cursor down where the landing site is planned to be. Thank you, Ian. Really appreciate you pointing that out. It's right at the edge, the day-night line on the moon, which, as you know, is called the terminator. We can also probably get a good view from Chris Vaughan's Starry Night program, but I think it's neat to see what it actually looked like through a telescope. Unfortunately, that was yesterday, because not only is Ian having a little trouble with his internet, he's also having some cloudy skies. So this is, if you're new to astronomy, it's pretty typical. You never know when you're going to get clear skies or not. So Chris, you've got the south pole of the moon pulled up?
I do. It's not emulated all that nicely in the program, but I just, you know, I've got actually the moon turned upside down, so we're looking down on the south
Well,
pole
which
of
way
the
is
moon
up
right now.
after all?
Yeah, that's right. Well, so yeah, so you can see here the this long stick is the actual south pole, which is the rotation axis of the moon, and then because this particular skin of the moon that the software is using doesn't have a sort of a flyover of the south pole to make the picture nice. They get a little stretched out, but you can see there's the crater Shackleton, which is labeled right here near the stick of the pole. And the crater Shackleton will be kept in shadow, and therefore any frozen water ice that's there is preserved because the sunlight never reaches it because it's at the pole. And so that's the point, is to head to Shackleton and be able to mine the water that's the ice that's available and make water and fuel out of it.
So one would hope that this mission goes slightly more smoothly than Shackleton's mission to the South Pole of the Earth.
That's right. They won't speak of it. Yeah.
We won't speak of it. Yeah, it's a fascinating story. Excellent. Thank you very much. We have a couple of more questions that came in. In fact, Chris, maybe you can answer one of these. Eric asked that he heard last month that a defunct satellite was going to collide with the moon, and we might see some photos of after the event from lunar orbiting spacecraft. But I haven't heard about any photos yet. Do you know anything about that, Chris?
I have a feeling it happened, but I don't think we've seen any results yet. No.
Okay. I believe Bhairavi had an answer here. She's put it in the chat in our program here, saying the photos will take about 6 months to get confirmed. So there you are. It did get photographed, but it'll take a while for them to confirm it. Excellent. Another question.
Sorry,
yeah.
I guess I just got unmuted. I was going to say, so yes, they kind of know where it was going to hit, but really it does take a lot of detective work to go back and look at newer images from orbit and then confirm if that has actually happened. So the entire process does take some time. So the earliest might be 6 months, but don't hold me to it.
Okay. That's good. Okay, well, something to look out for. Very interesting to think about space pollution. I mean, we've obviously heard a little bit about that recently with all these things we're putting up in space and plans to safely deorbit them, probably crashing them into planets. Not necessarily a good idea. Not sure. Well, here's another question that came through. How long would it take for humans to establish a permanent lunar colony? That's an interesting question. I'm not sure who'd like to take that. Bhairavi, if you're still with us, maybe you'd like to have a go at that one. Any idea?
I think, I mean, there is no clear timeline present, but really it all depends on how the Artemis missions go and what that tells us in terms of establishing something on the lunar surface. So with Artemis III, that is the first time that they would be able to test it. And from then on, start to get a better idea on what is the better, like perfect setup that ensures astronaut safety, but at the same time to ensure that it can, you can maybe set a more permanent base. So stay tuned. Maybe by the end of this decade, it might be a little more clear.
Excellent. Okay. For our observers out there, unfortunately, we've sort of lost audio from Ian out in Nova Scotia. But maybe Francoise, if you were interested, do you think this is going to create the kind of buzz around space and astronomy that the Apollo missions did? What do you think?
didn't quite catch that question. I had two people speaking in my ear.
No problem. I'll repeat it. I was wondering if you think that this Artemis mission is going to create the same kind of buzz that the Apollo missions did, and maybe spark some interest in space and astronomy, just like those missions did. Do you think it will?
I think it will once we start to see the actual science. I remember actually saw the Apollo 11 landing when I was a young kid.
Mm-hmm.
And it was exciting times from launch right through to landing and finding out what sort of science was being done. I think because this is a new group of younger people who have never experienced that, a new generation, that it will start to really get them going and get them interested in the science, and especially with the emphasis on STEM that is happening. Mm-hmm. So I do think that will start things going.
Yeah, I certainly hope so. I have sitting next to me the teenager who was in the video earlier, who's listening in here a little bit. And when I asked her about this, obviously you saw her answer, but she's already interested in space. So I think space is one of those things that has a natural kind of hook for people. And it's only going to get better when we think about actually going to places. I have some information from Ian just because his audio isn't working. He'd like people to know that the video he was showing us was from last night. It was a 13-centimeter telescope with lenses that make it appear to have a 2.5-meter focal length. So the smallest detail visible in the video is about 1 kilometer across. So this is kind of interesting to put things in context. They look like they're really close up, but we're still seeing something that is quite far away. And it's remarkable that we can see that detail through telescopes, and even more remarkable that we're going to land people on it. I think that's an amazing thing. All right. Any more questions coming in? This is your last chance if you're watching on YouTube. I'd like to thank you for coming tonight. And if you have more questions, throw them in the chat right now. Think about things that maybe interest you, the most exciting thing that you yourself have seen on the moon. What is the most exciting thing that you've seen on the moon? Maybe I'll ask Dennis that. Dennis, if you're with us, what's your favorite lunar target?
Hi there. Yeah, it's the thing that I found most interesting was I read this fantastic book by Charles Wood, and he's made a habit of studying the moon. And there's this thing called, oh my goodness, gamma Riga or Riga gamma in the western part of the moon, and it's this funny swirly thing, and it's right near a whole bunch of volcanoes that are actually, you can tell they're volcanoes. Volcanoes on the moon are very liquidy, like they didn't build big shield mountains like you see sometimes. They're kind of like, like 1 or 3 kilometers, maybe they're kind of humps. But if you get the right light, you can see these volcanoes and go, yes, there was volcanoes there. But this Riga gamma thing, it's like a magnetic anomaly, kind of like the one in 2001. Maybe there's something buried there, who knows? But they don't know why. It's like a piece of a magnet that's just cut off from everything else and just kind of hanging out there, and it's a cool thing to see in the telescope. There's lots of other things to see on the moon. The moon is full of interesting stuff to look at, but that's one of my faves.
Thanks, Dennis. Chris, I just want to finish up with a question for you. I wonder if you have an opinion on this. In light of world events, how important is it that we undertake space exploration like this? I threw you a hard one.
Well, hopefully it supersedes international, borders. I mean, we're all humans. We all strive to learn and know more, and it's inspiring. I think a lot of us on the line tonight and a lot watching were probably inspired by the Apollo missions. I know I was, and it led me to this sort of a joy of my life that I get to explore and to share the wonders of the universe with everybody. And, the fact that Artemis is designed to be inclusive and appeal to a whole other demographic that wasn't part of Apollo, the young ladies and people of color. I think it's fantastic, and I'm optimistic that I think we can do great things if we work together.
Fantastic. Thank you so much, Chris. I'm joined by Julia, my daughter, who recorded that video earlier. She is also a member of the Toronto Centre, along with me. And so hopefully next generation will be inspired by Artemis. Maybe you'll go to the moon. Maybe. All right. I think we're going to close, if we can, to get in Wheelband's video back up. And I'll give just a few closing remarks. Or we hope that watching tonight has helped you discover the joy and excitement that space missions and astronomy bring to all of us. If you're new to the subject, I recommend starting by getting to know your sky a little better. If you want some help with that, please consider joining your local RASC Centre. We are here in Toronto. There are other centres around the GTA, Ontario, and across the country. And if you're somewhere else, as some of you are, you can always join the RASC, but I'm sure you'll have a local club as well, and they'd love to welcome you too. We hope that you've enjoyed this presentation tonight. You can follow along with Artemis developments with the RASC, the CSA, and NASA, which now you all know what they mean. So again, my name is Kirsten. We're from the RASC Toronto Centre, and I'd like to thank you very much for joining us tonight. Have a good evening and clear skies.